a long journey. As always, we have our attendance form. Why is it so loud? Has everyone gotten the attendance form? I'm assuming everyone has. So, some quick announcements. The hackathon kicks off on the 14th. So that will be 2 weeks from now. There will be more information coming soon. Everyone is required to come to this, and this is where bulk of the information about the hackathon is given. So after this, there will be 4 bonus lectures planned for the 7th, 14th, 21st, and 28th. These are just bonuses to give you extra credit, and or if you're feeling like you want to learn anything extra. So what are we going to be teaching in these bonus lectures? Well, we'll be teaching you about the frameworks that Aptiv uses on a daily basis. So as previously mentioned, there's extra credit offered for showing up, and there is also optional additional bonus homework on these lecture materials. So for the bonus lectures, we'll start the following week with Jetpack Compose. It is a newer and shinier framework for Android development that Aptiv has slowly rolled out onto a majority of our apps. So we have slowly transitioned almost all of our apps into using Jetpack Compose due to the fact that it is a lot more easy, as well as the fact that it fixes a lot of the issues that has previously plagued Android development or Android Studio. So hopefully you guys come. It's not necessary. In addition, there is no cap on the homework slip days for homework 6, so there's nothing left. Previously, it was 2 per assignment, but now you can just use the rest if you need them. And finally, for homework 6, we actually use real backend, and as a result, it is going to be pretty tedious, and so hopefully you guys get on it as soon as possible. So, any questions before we get into the actual lecture? All right, there's none. So, today we will be teaching you guys about data. More importantly, it is how data persists throughout your entire app. We've previously learned a bit about how data is propagated using bundles. When we were using put extra with our intents, when we were passing data between activities, you might notice that we were using these things called bundles. And specifically, you specify any additional information to the intent inside a bundle. As a result, the resulting type of the getExtra call from the resulting activity from the intent is a bundle with a key that is used to access the various data that you've stored within it. Bundles are limited in the sense that you can only use it to transfer information between activities or between fragments. So what if we want our data to be globalized? How do we want, we don't actually want to keep on passing information between one activity to the other. We just want to be able to instantly access this core important piece of data throughout any part of our app. How would we do this without constantly transferring this piece of data between all aspects of our app? And the solution will be singletons. You may have learned these in 2110 or 2112 if you took them. Their basic idea is that this data structure is where only one single class can be instantiated. And in this case, it also holds data from across the app, all in one place. And in general, it is frowned upon for complex apps, but it is still widely used in the industry, and this will be what we are using in order to ensure that data is able to be accessed on globally and within your app. So name singleton just means there can only be one instance of this object or class. So there are some specific singleton rules. Before I get into this, what Kotlin does is it makes it very easy for you guys to actually, create singletons, because it automatically fulfills these criteria. So what are these criteria? Well, first of all, we need a private constructor. This helps prevent the class from being able to be instantiated more than once, right? Second, it needs globally accessible object references. This is just due to the fact that we want the information within the singleton to be able to be accessed throughout our entire app. And so it is important that we give it the ability, or give other classes the ability to access these objects on a global scale. Finally, we need consistency across multiple threads. This third condition is something that you do not need to worry about, as you guys are all most likely sophomore and or freshmen, and if you have not taken an operation systems class, there's no need to remember this because you're not going to be doing any threading of sorts. But these are the 3 rules or requirements that are needed in order to ensure that a singleton actually works. And just to clarify, once again, Kotlin makes it very easy for us, because when we build it, it will automatically fulfill these requirements for you. So how do we actually go about building these singletons within Kotlin and within our apps? Well, here is an example. Simply, this is a centralized counter. What's important about this is we have this keyword called object right before our singleton. And here in Kotlin, object is a special keyword that is used in order to create a singleton, right? It is a special class that can only have one reference. If you create a class with the object keyword instead of a class keyword, as we have seen previously, the Kotlin compiler will make the constructor private, create a static reference for the object, and initialize the reference in the static block, which makes it always thread safe, which automatically fulfills the contract or the singleton requirements that we've previously specified. There's, for the actual code, we have the counter, which is globally referenceable. There is an optional initial block if you want to actually initialize some of the values within the singleton when it's created for the first time. And finally, you can also incorporate some functions that can be called globally. And here we've incorporated increment counter, which just increments the global accessible counter instance variable. Next, we want to talk about persistent storage. What is persistent storage? Well, say for example, you're creating a game. Well, if you might have noticed, say for example, when we're making our apps, when you leave the app and you go back in, you might realize that the changes that you've made inside do no longer appear. And this is due to the fact that every time you exit and you go back in, the data that is within it is not permanent. And as a result, we want to use this thing called persistent storage in order to store important data that we want to be able to be maintained through different uses of this app. So say for example, we have a game that has a high score, right? We want to maintain this high score throughout every single playthrough of this game. And some other examples could be logins. We don't want the user to log in every time they open up the app. We want to actually store this information so that, or cache it so that they don't have to log in every single time they open this app. And there are a lot of other reasons why we want to store these things. Maybe, for example, there is a lot of information we need to ping from the backend, and it'd be better and quicker if we first stored on our app in our local memory and then easily access it through there instead of always pinging the backend. So there are a lot of reasons why we want to use this, and today we'll be introducing a simple method for this called shared preferences. Shared preferences offers a framework to save persistent data in a key value pair, very similar to the bundles that we've already worked with. So it works with any primitive data type, meaning booleans, ints, longs, floats, and or strings. How does this come in handy? Well, shared preferences makes it incredibly easy for developers to store user states when it comes to user settings, favorites, or just keeping track of important information without needing a storage permission, which can be very tedious and is not always guaranteed, as the user can deny permissions as they are classified as dangerous permissions. A downside of shared preferences is that these set preferences are deleted if the user actually deletes the app and or if they clear the cache or data of your app. So for a more permanent solution, you might want to actually coordinate with your backend to store the most important data that you want to last. The positive is that this is incredibly simple to implement in comparison to actually networking with a backend, and yeah. So we actually have, so here is some of the actual syntax for how to actually use get preferences. So starting off, we actually want to create a file of sorts to actually store this information. And to do this, we can use this function called get shared preferences. What this does is it either creates or it accesses a file that you've created internally with the name preference name underscore name, right? So the reason why you would use this get shared preferences is because you would like this value to, or the values that you are storing on this file, you want to be able to access them on different activities within your app. So there are two arguments or parameters that we have input into this function. And the first one, as I previously mentioned, is the pref name. This is the key to the actual file, and it's kind of, you can think of it as the file name. This must be unique, so we can actually identify and access this file. And the second one is called content mod prime. This means that your app can only your app can access this file. So say for example, you're storing credentials, you're storing sensitive information. In general, you always want to use this mode because you don't want other apps to be able to secretly access the information and potentially do some hazardous things with the information that you might accidentally provide. Next, we just have get preferences. The only difference with this one is that this one is linked to an activity. And as a result, it means that when you use get pref instead of get shared pref, the data is stored and uniquely stored on this one activity. As a result, we don't actually need a key for this one because the file that is produced out of it is uniquely tied to the activity. Next, now that we've created the actual file, we want a way to be able to input values into our file. And for this, this is the simple syntax. What we do is we take the shared pref that was returned from us and use this thing called .edit. .edit returns an editor, and we can use that in order to put ints, put strings, the same way we've done it with intents. You do the same thing where you have a key and then the value. So it is simply just a key value pair like we've previously seen. And then afterwards, after you've put all these values, you need to remember, and this is very important, to actually commit or apply these changes. Because if you do not commit them, they don't actually get committed, right? So what does commit do? What is the difference? Well, commit saves the values immediately. It says, hey, when this code is immediately run, we will save it immediately, while apply saves the values asynchronously. Next, you might be wondering, so next, say we actually want to retrieve these values. We've just set them, right? We actually want to retrieve them. Well, in this case, we use getInt, right? And here you might notice that there is a second parameter. What is the second parameter? Well, it is just the default value, just in case nothing is returned. Let's say you haven't set key. Well, instead of returning null, which is not something that we want, we will just return our default value, which we have previously set, and in this case will be 0. Now let's talk about networking. Networking is one of the more difficult components of actually building an app, and however, it allows us to improve on the dimensionality that we can and how we can use our apps specifically. So in general, it is just being able to access the internet and or a database for information. So these are some terms that we would like for you guys to know. There is the client. This is you. This is your mobile application. And the client wants to communicate with the server. The server in this case would be the internet, it would be your backend, right? And the client will make a request, for example, to the server for information. The server will give that request to the client. And the API is defined on how the client and server communicate. As a front-end developer, you'll be focused on the API, as this is a contract that specifies how the interaction goes between the client and server, and it's sort of like a contract of what type of inputs the server wants to receive in order to get the information that you want. Most of the time, what is responded back from some API is a chunk of data, and most likely you will encounter what is called a JSON. And a JSON is just a way to actually store data in a readable way. So, to get into more detail on what a JSON is, JSONs are JavaScript object notation. In other words, it is a minimal, readable format for structuring data. And the most important thing that you guys need to remember about this is that there are key value pairs, right? You have a key, and then it is paired with a value. And the values must be valid in JSON format. So the JSON data types include strings, numbers, objects, booleans, and nulls. So this is just an example of, for example, a JSON that can be returned. Here we have, first of all, the employee. This is the key. The value here is everything after the colon, which would be this entire block of code, which is an array. To represent an array, we have a square brace bracket. So everything within the square bracket is within the array, and everything within the curly brackets are an object. So here we have an employee, right, and it is storing 3 objects, and these are just the first and last names of individuals. So JSON structures can be very, very complicated, and for us, in our case, it's very, very difficult to parse all of this. And so there are a lot of libraries available to Android in order to make this navigation a lot more easy. And one of these APIs are called Moshi, which we will teach you about very soon. So, as previously stated, we don't actually want to parse JSONs ourselves. We want to actually use third-party APIs to be able to do it. And so homework 6 will involve reading an API for a backend. And in addition, for your hack challenge, you'll be actually having to deal with, because you'll have a backend member on your team, you'll have to ask them to provide you APIs to be able to access the information that they have on their backend. So let's talk about Moshi. What is Moshi? Well, as previously mentioned, it is a headache to actually parse a JSON file. There are a lot of curly brackets, there are a lot of colons, right? There's a lot of square brackets, and this is where Moshi comes in, because it easily converts a JSON file into a column object that we can easily access this data from. So Moshi allows us to, again, convert JSONs into Kotlin objects seamlessly. And the nice part is you get to define the data class in a particular way so that Moshi will automatically convert a JSON file into an object. And it's just a little fun fact to enforce how useful, Moshi is. We actually use Moshi on Eatery right now in order to turn our data from the backend into our Eatery objects. So this is an example. Here we have a riddle as a JSON file. So here we have, in this JSON, we have a title, which is of type string, called the impossible question. There's a question, and there is an answer, right? How would we actually go about parsing this using Moshi? Well, here we do what is called, we use these two @ symbols called JSON class and JSON annotations. And so JSON class tells Moshi that this class represents a JSON object, and JSON tells Moshi that these are the JSON fields that are needed or need to be mapped to these specific instance variables. So here we see the JSON name equals title. So that means if I see a key with the name title, right, I'll parse that information into the actual value title. And same goes for the question and for the answer. And so now all you have to do for this, to be able to parse everything, is just name the actual object, name the actual key, and then Moshi will automatically parse that into the value that you have here. So this makes it very easy, because you don't actually have to do any of the parsing other than just naming what keys you want to be able to access within this data class. Finally, what we need to do is to make an adapter to specify it to your data class and then pass in your JSON. So this is just the simple syntax for it. After all this, basic standard code, myRiddler, you can do myRiddle.title, and you will be able to actually get that information and then do whatever you need to do with it. Right? So myRiddle is now a fully built out data class. Okay, so Moshi can turn these JSON objects into Kotlin objects. But how does one actually make a request to the backend in the first place? Well, this comes our next API or third-party library we are using called OKHTTP. OKHTTP allows us to pull data in the form of a JSON object from our backend with ease. OKHTTP is much easier and more intuitive and has a natural flow than the native HTTP request support, which makes it our preferred HTTP requester. So this is just an example. Here we have the API specifications for getting a random riddle from this website. And this is the GET request that is required. Requires a header called XAPI key. And it is just the API key associated with your account. So to actually get this request, here's some code. We have the client, which is just our HTTP thing. And then to build our request, we just do request.builder, and we set the URL, set it to a GET request, and then have a .add header, which adds in the values that we need to actually be able to ping this back, or ping this URI. So .get, as a reminder, specifies that is a GET request, and then .add header allows us to add the required API key so that we can actually access this backend. Finally, to actually launch a request, we need to do all this, what's it called, standard code. And all this does is say, hey, look, now that we've made the request, you need to be able to actually handle what happens. And here we have a on failure and on response. So it says, hey, after everything's happened, there will be a callback, and it will either fail or it will either succeed. And in either case, you need to be able to handle what happens next, right? If it fails, what will happen? You put that in the block of code up there. If it succeeds, what will happen? You want to put that in the block of code underneath. And for our case, if it succeeds, we want to actually parse it. And this is where we actually put our Moshi code in, on the on response part. In addition, OKHTTP also supports post requests, which is just you writing information to the backend. And it is very, very similar to our, the GET request. And so the details will be posted on, or our textbook will have a detailed walkthrough of how to actually go through that. Now, onto the demo.
Okay. Alright, let's see if this microphone cooperates. That seems pretty good. Okay, so I will be going through a demo of basically just using the OKHTTP and Moshi adapter in order to pull some information from a backend that I found online. Specifically, this backend will be able to take in a word and actually give you the definition of that word. And so we're making a sort of dictionary definition app, if you will. I'll drag my Android Studio over. Hopefully I'll be able to see this. Check that my recording also did not mess up. Very important. Okay, well, that's fine. Alright, so the first thing you want to do if you want to use HTTP or Moshi is to go to the textbook and add the dependencies that you need in order to use these third-party libraries, because they, after all, are third-party and not natively inside Android Studio. So the first thing you have to do for Moshi is to go into your Gradle scripts and go into, not this one, but this Gradle file, and plug in Kotlin Cat. Of course, all this is on our website, and the dependencies here. Okay, and these dependencies are enough for Moshi, and we'll have to add some more for OKHTTP. Those, again, are on our website, so I'll just copy those over. And after that, we should be able to hit sync now. And hopefully that's not crashing or. So hopefully now. I'll just turn off the microphone. It's not recording. Hopefully now the OKHTTP and Moshi will now register in the app. We'll just quickly check that out. HTTP, and of course, OKHTTP now shows up as a class, which means Gradle was seeking it correctly. So the first thing we'll want to do if we want to use an API is to first look at the API specification. So let me pull up the API specification for dictionary. This is their specification. Pretty much your dictionary will accept a GET request, and you need to pass in a word as a parameter, like so. You would use this URL, and then pass in the word here as a sort of appending to this URL. You also need to pass in the API key. Again, the API key is just a way that these public APIs track who is using their APIs, and so they can limit and make sure people don't spam their APIs and overload them. But most APIs you'll be communicating with, and especially on your hack challenge, should not need an API key like this. But in real use cases, you might need something like this. But anyways, this will take in a GET request and those parameters as follows. And if your request succeeds, it will return something like this, which is a definition, a word, and a valid. All of these are keys, and their values are first strings for definition, another string for the word, and a boolean for valid. So knowing this, we can go and make a data class that sort of represents one definition. So we'll need a data class that has a definition that's a string, a word that's a string, and a valid that's a boolean. So let's just go ahead and make that. Let's go to file. This is breaking my neck over here trying to look on the screen. There we go. Cog class, and we'll call this a definition. We'll just change this to a data class. Data classes, again, can't have really much of a body. They can only have instance variables. And you write this like so. And now you just define the variables here. So we'll need a definition. That is a string. A word, that's a string. And a valid, that is a boolean. And that should be fine. And the next thing we'll need to do is add those annotations that you saw in the slides. So first add JSON class and generate adapter to true. This will make it so Moshi automatically tries to make a generator or an adapter for this particular definition data class so that it can take JSONs and automatically create definition objects. Next thing is to add these @JSON annotations to each instance field or instance variable. And we'll have to pass in a name that corresponds to the name of the JSON field. So the definition naturally will correspond to the definition field of the JSON. Same thing for word. And for valid as well. Now, I actually put the valid name. Now, one thing to note is that because I named these fields definition, word, and valid, I technically didn't need to put these annotations here because Moshi is smart enough to know, okay, if something is named literally exact same, then I'll just automatically put it in here. But if I wanted to say change this field to my definition, now since my definition doesn't necessarily link up with definition, this annotation now actually comes in handy in order to say which field in the JSON should correspond here. But just for simplicity, I'll just keep this as definition. Okay, so now this is our completed data class for definitions. Now we have to actually make our requests with OKHTTP. So let me make another class. Okay, got it on the first try this time. On a class. And just like how you saw in your homework 5, or maybe are seeing in your homework 5, they had a getPicture function which sort of made an API call with OKHTTP and made a took in a callback function that would allow you to do stuff once you've got your request. And we're going to make a similar function, like very, very similar, right here. So I'll call this networking utils, and I'll probably file class. And so the first thing we want to do is make a function that gets the definition for a particular word. And of course, we want to make a callback function. Now, one of the things about Kotlin that makes it very unique from Java is that it kind of has functional aspects, which you'll learn about in CS3110 if you haven't already taken that. Basically, it can take in functions as values or arguments. So here, I'm going to specify a callback function that takes in a string, that's the definition actually. The definition that I would get from the backend and then do something with it. That it shouldn't really return anything. So unit is the thing, I'll say that returned. And unit is basically the equivalent of void in Kotlin, like Java's void. So basically nothing, it doesn't return anything. So now I can run my function. So the first thing I'll want to do is make I guess before I do anything, I want to first make sure that my permissions are properly aligned. So I have to put in networking internet permissions so that I can actually make network requests. So I'll just throw that in the manifest. Those are on our textbook. And so the next thing I want to do is actually make a OKHTTP client. So I have to do that with client equals OKHTTP client. Just like that. No more has to be done in that case. Next, I'm going to make my request. And so you do that with the request builder, as you saw in the slides. So you have to import the OKHTTP3 one. And so here I can specify my URL, if it's a GET request or not, and also my header. So my URL is going to be, let me check the API stack again. Just copy over the URL there. Leave this guy here. And I need to sort of append the word on the end of that. So I will do that. this, I'll want to put on the word. This is some little fancy syntax that I kind of just learned, where you can sort of specify a line of code that will return a string, and so I don't have to write like a concatenation with word. I can just kind of write this function here, and it'll return whatever this is, which is just a word. So kind of nice. Might want to use that because it makes string concatenations way more clear, or way more concise. So next, I want to put in get, since this is a get request. That's the next line, and put in my header. So I would trust that you guys will not steal and abuse my API key. I do have the power to change it, so if you guys start deciding to make malicious requests with my API key, I will have to go into my account and change it. I'm going to assume that you guys won't do that though. Here's my API key for the world to see. And so I'll have to align this with the specification. So let's move quickly back to that. So this says x-API-key. So that's what I'm going to put the name as, x-API-key. And put in my API key. And now the last thing I have to do is .build. Now this should be a fully built request. And so now I can actually have to send this request, right? With the OKHTTP client. And the way to do that is with client.new call, pass in the request, and do .enqueue. It's pretty much just asynchronously says we want to make this request. And so this will take in a callback object, which is kind of like a on-click listener, if you will, in which whenever you get the response back from the API, you will call this or do whatever is specified in this object. So just like a click listener, click listener, import the right one. You have to import the right functions for this. It's because callback is an interface. So I'll just roll over this little squiggly, import members, and override these two functions. There we go. Very similar to a seek bar on click listener. So on failure, I'll just leave that blank for now. You'll probably want to display some sort of error message in actuality if that occurs. But on response, what do I want to do? Well, this response will, first of all, have a JSON body. So in order to get that, I'll say val body equals response.body. And now I want to actually use my Moshi adapters in order to turn the response body, which again is a definition, a word, and valid, into a definition object. So that's where the Moshi comes in. So in order to do this, we first have to make a Moshi instance. And this is of type Moshi. And I'll say Moshi.builder.build. Just kind of syntax you have to write it. It doesn't really mean anything. And next we have to make our adapter. So this, I'll call this a definition adapter since it'll take in a JSON, turn it into a definition. It should be of type JSON adapter, and the generic type you put in here should be the type of object that it'll convert the JSONs into, which in this case is a definition. And now we can say this is equal to our Moshi instance dot adapter. It's basically just going to make a new adapter of, again, this type definition, and put in the definition class. Again, this syntax, kind of a handful, but it is on our textbook. And okay, so now in order to actually make a definition object from my JSON, all I have to do is, well, make something to hold it. So I'll say my definition equals, and I'm going to use my adapter, which is again definition adapter dot from JSON, and then pass it into my JSON. So this should be body dot source, and I think this is null. Yeah. So this technically may or may not return null. So I'm just going to force null. Probably not the best way to do it. Or maybe here also. Yeah. There we go. Okay. And now my definition should end up with a definition object. Now the last thing I have to do is actually use my callback function in order to, where is that? My callback function, in order to actually do something with this, my definition, because otherwise it's just sort of hanging around here, not actually doing anything. So I'll want to pass this into my callback function, and then whatever this callback function is should operate using this definition that I just pulled. Okay, so now I'll go back to my main activity and actually use this function in order to make a call for a specific definition. So we'll use this function. What do I call it again? Where is it? Get definition. And let's say I want to define a word. I'll say Android. And I can either specify a function like so, in which it kind of looks like I'm actually passing it as an argument, or just shorthand, you can do it like so, where you pass in the argument, or pass in the function sort of after the function call. Either way, you can see this is calling an initial parameter it as the definition. I can change this name from it, which is the default name, to something else, to more intuitive. I'll call it my definition, my def. And now I can assume at this point that my definition is a definition that I had received from the backend and actually took from a JSON object and made a definition object. So now all I have to do is sort of treat this as an arbitrary definition and do whatever. So in this case, I'll just make a debug statement to make sure it actually works. I'll say definition debug, and pass in, let's say, I actually make like a more intuitive statement. I'll say the definition of, or I should be able to say my def dot word is, and then my def dot definition. That should honestly be good enough. So I guess we can try that. Load up my emulator here and see if my logcat returns the correct definition for Android, or at least a generally working definition for Android. It's still loading up. Android Studio takes incredibly long. Hopefully that doesn't take too long. But yeah, I've seen that some people have been having some trouble understanding the sort of idea of passing in a function as an argument. We will be going over sort of these quirks of Kotlin in one of our bonus lectures, where we go over sort of the intricacies of Kotlin, functional programming being one of those intricacies. But I think our thing just loaded up. There should just be nothing really on here. Let's just pull this over. Shouldn't be really anything on here because I just made a debug statement. But as you can see, it actually did pull the definition of Android, which is resembling a man, and for some reason there's a couple new lines here, a machine or automaton in the form of a human being. And just to make sure, just to prove that I didn't hardcode that, let's do something else. Let's say world, as in hello, but I can't pass in both words because that is not one word. So let's try that again, and let's see what happens. Okay, the definition of world is 1. The earth and the surrounding heavens, the creation, the system of created things, the existent creation, the universe. Oh my gosh, that is a long definition. Okay, well, as you can see, it's working at least. So it's actually pulling the definition of world from this API. Now, I guess in the last couple of seconds, I have about 5 minutes, I should be able to make some sort of layout for this. Because right now, I mean, if I'm a user, I just see hello world, I don't actually see anything happening. So if I can speedrun build something here in the layout editor, I will try my best. Say I want to take in an edit text to take in a word to define. That's small. And then constrain it as follows. Get rid of that padding. Bring it to the center there. And let's give this a hint text of enter a word. Throw a button underneath this, constrain it horizontally to that edit text. Put it underneath. Add a little bit of padding. Say define. And then we'll have a sort of results text on the bottom here to actually show the definition. Let's constrain it horizontally. And we'll say put this in the middle between this and the empty space. And make this a little bit easier to see. It's kind of small right now, with a bit of a better text color than the default. Okay, so our definition should go here. And so now let's just add some logic to sort of take the word that they've input here, that our user has input here, And once the button is defined, or once the button is clicked, it'll pull from backend the definition of the word specified here and throw it into this edit text here. So, or throw it into this text view here. So of course, we'll have to use our trusty find view by ID. Writing find view by ID calls is my favorite pastime. ID dot edit text. That sounds about right. Let's just go there. Text view. Probably text. No, not that one. Text view. Also go there. And income equals find view by ID. Oh no, the ID button. Okay, let's hit the build button, hope the errors go away. That's how I solve my problems. So we'll make an on-click listener to listen for a click. And when this button is clicked, we'll have to take what word is defined here in the edit text, throw it into our get definition, and then use the callback function to take the definition it pulled and then throw it into the text view. So let's run through that. Make a get definition call with the edit text's current text as the word. And I guess we can just throw that to lowercase. And now I'll have to throw in our function. This is again the callback function, so this will execute after our definition is already successfully pulled, and then I can say text view dot text equals my definition dot definition. Now I think this should throw in an error. I hope it does. Sometimes, like maybe like half the time throws an error, and I want it to because this is a pretty common source of confusion. So let me just try to define the world again. Honestly, this definition is so large that it'll probably go off the screen. Okay, yeah, threw an error. Let's see what that error says. Okay, yeah, so whenever you're working with these API calls, you're very likely to get this error. Only the original thread that created a view hierarchy can touch its views. Basically what this is saying is the thread that's running the API call can't actually touch the thread that your layout file is sort of rendered in. These are two separate threads that are working simultaneously, and only the thread that is working with rendering your layout can actually touch and edit the layout. The API calls are working on a separate thread, a separate sort of flow that is unable to access the layout. And in order to force code to run on the layout thread, all you have to do is throw in this little bit of stuff, run on UI thread, and then put your editing UI stuff in that block of code. So this should hopefully work now. Let's try to define world. I really wish I put down button. Oh boy, that is one hell of a definition. Let me close that. Okay, wow, that is quite the definition. So it was even going off screen, but anyways, it works. Just maybe not incredibly pretty. But of course, we don't really have time to make it pretty. This is just a working demo. In the demo code I will post later, I have gone in and actually made this format nicely with a little scroll bar. So if it goes off screen, you can scroll through the definition. But anyways, this is pretty much brought us to the end of lecture. So if I might bring up the final slide here. Of course, your homework 6, your final assignment, is due the 6th. That is Sunday at the usual time. But again, thank you all for coming. This is, in fact, the last lecture. If you guys do not show up to the bonus lectures, of course, we do encourage you guys to come, since you will get extra credit and actually have a look into the frameworks that we on Aptiv are using to develop our apps. So if you're interested in Aptiv in any way, we heavily encourage you to come to these bonus lectures. But other than that, that's all we have for you today. So thank you all for coming, and hope you have a good night.